So this example is from a Cambridge A-level mathematics past paper, May-June 2018, question paper 11, and we're going to be looking at question 6 part 1 in this video, and in the next video we're going to be looking at part 2. So let's look at the question. The diagram shows a circle with center O and radius r centimeters. So as you can already identify, this is a sector. Remember that a sector is basically a chunk where you have two radii and you have an arc and that region inside. The entire region, that's a sector. So it has radius r, and remember that the radius of a circle is the line drawn from the center of the circle to the circumference of the circle. So OB is also the radius of the circle, so that's also equal to r. The question hasn't put that there, but for you to infer that the length OB is also r centimeters, because the length OB is also the radius of the circle, because we're also going from the center to the circumference. So this is also the radius, that's the radius, so this is r, this is also r. The points A and B lie on the circle, so A is on the circumference, B is also on the circumference, and AT is a tangent to the circle. Angle AOB is theta, and OBT is a straight line. Express the area of the shaded region in terms of r and theta. Now, whenever you're looking at these questions, you have to understand what each statement is telling you. So, if AT is a tangent to the circle, then this angle here is 90 degrees. It comes from circle theorems. When you were doing GCSE maths, you learnt about the 4 circle theorems, and one of the circle theorems was that if you have a line that is a tangent to the circle, and then you draw a line from the center of the circle to touch that line, the angle between the two is 90 degrees. Okay, let me repeat that again. If you have a tangent to the circle, for example AT, if you then draw a line from the center of the circle to connect to that tangent, then the angle between the two is 90 degrees. So here we have a tangent here, AT, and then here we have our radius, which is a line drawn from the center of the circle, and it's touching the tangent. So this angle here is 90 degrees. This is from GCSE knowledge. We don't learn about this in A levels because they expect you to know this from your GCSE study. So circle theorems will come in when you're dealing with these problems. So you need to understand that. So this angle is 90 degrees. And if this angle is 90 degrees, then it tells you that this triangle AOT, it's a right angle triangle. It's a Pythagorean triangle. It's a right angle triangle because this is 90 degrees. So ATO, AOT, however you want to look at it, this triangle here, it's a right angle triangle where this angle is 90 degrees. 90 degrees in radian language is pi over 2 radians. Pi over 2 radians. So this angle is pi over 2 radians in radian language. So express the area of the shaded region in terms of r and theta. So I've drawn the same diagram here, and then this is the area. This is the area that I want to find. This is the area that I want to express in terms of r and theta. Now, quite simply, if I want to find the area of the shaded region, I'm going to find the area of the entire triangle, and then I'm going to subtract the area of the sector here. So I'm going to find the area of the triangle AOT, and then I'm going to subtract the area of this sector here. If I find the entire area of the triangle and subtract the area of the sector, I'm going to remain with the area of the shaded region, which is what I want to find. Okay? So now, what is the area of the triangle? Well, if it's a right angle triangle, we know that the area of a triangle is equal to half multiplied by the base multiplied by the height. That's the area of a triangle. So the base of the triangle in this case is the radius, which is r, okay, which is r. So then that's going to be equal to a half multiplied by r multiplied by AT. Okay, so it's going to be half multiplied by r multiplied by AT. Now, the question says we need to express this area in terms of r and theta. So I need to somehow express this AT in terms of r and theta so that I can replace it here. So how do I find AT? Well, I can take a look at this theta here. Remember, this theta is inside the triangle, and I can use my SOHCAHTOA. So sine of this theta is the opposite AT over the hypotenuse, which is OT, Cosine of this theta is the adjacent, which is r, over the hypotenuse OT, and then the tangent of this theta is the opposite AT over the adjacent, which is r. Okay, and that's the one I'm going to use. So the tangent of theta is equal to AT over r, which implies that AT is equal to r multiplied by tan theta. So AT is equal to r multiplied by tan theta. So tan theta is equal to AT over r, so AT is equal to r times tan theta. And then I can then plug it in there. So my area, therefore, is equal to a half r multiplied by r tan theta. Okay, a half r squared multiplied by tan theta. A half r squared multiplied by tan theta. So this is going to be the area. This is going to be the area of my triangle. Now I need to subtract the area of a sector. Now I need to subtract the area of the sector. The area of a sector is equal to a half r squared theta. Okay, it's equal to a half r squared theta. This S stands for sector. My radius is r, my theta is theta. So this is exactly the area of the sector. So the final area is going to be a half r squared tan theta minus a half r squared theta. And that's it. That's going to be my final answer. So this is the area of the shaded region. It's equal to a half r squared tan theta minus a half r squared theta. Half r squared theta is the area of the sector. So I figured out the area of the big triangle and I've subtracted the area of the sector, and this is my final answer. If we're going to check the mark scheme, this is our answer. Area is equal to half r squared tan theta minus a half r squared theta, and we get all our 3 marks. So this answer is correct. We get all our 3 marks. And that's how we look at part 1 of this question. In the next video, we are going to be looking at part 2. Until next time.